Okay, welcome to technical session number 4. We will be talking and doing a little bit of a deep dive on motherboards, getting to understand that piece of equipment a little bit better. Our objectives throughout this particular technical session are to first explain the key role of a motherboard, and then describe and identify the components and typical interfaces found on a motherboard. Talk about some required maintenance checks for motherboards. And then we'll get into the steps of installing a motherboard, using a BIOS a little bit, and configuring the motherboard. And we will talk about the replacement to BIOS, which is the UEFI. We will also identify some common pitfalls when installing one, common problems that come up with motherboards, etc., and then talking a little bit on how to solve those problems. All right, current behavior skills and mindsets we are going to need to keep in mind while working through this is adaptability, being able to continually change with your environment. I am getting a strong lesson in that today. And also persistence. Failure is a lesson. Each time we fail, we get up, we try again. If we cannot solve a problem on the first round, we give it another shot. We try it from a different angle. Even if it is something that we get up, we walk away from just to kind of clear our head for a minute, come back and look at it with fresh eyes. It helps a lot, but we want to keep persistent and continually press forward into the on the path to attaining our goals. All right, so what exactly is a motherboard? Donnie, can you read for us, please? The first two.
The motherboard, also known as the MOBO, provides the foundation for the PC since it connects directly or indirectly all pieces of hardware. It is a multi-layered circuit board containing copper paths called traces that carry signals and voltages across the board. Excellent, thank you. So it is, like we said yesterday, it is kind of like the backbone or nervous system of your body. It carries signals to all the various components, like your brain needs to transmit signals to your hands and your feet and whatnot to keep you moving. Motherboard is transmitting signals from the CPU to the monitors, to the hard drives, to the internet, and facilitating those communication between those devices. Some of these layers carry input-output data, other layers distribute power so those devices can function. There is a basic level of instructions on every motherboard when you first install it that allows you to do initial configuration and set up various things on your motherboard, like where to go looking for operating systems and stuff like that. And it's called the BIOS, which we'll talk about in a little more detail, which again stands for Basic Input Output System. It also has been updated to a newer version, which is called the UEFI. And trust me, when you go into one, you instantly know which one you're dealing with. We'll show you how you notice, and we will work with that. All right. Form factors. Sounds fancy, right? Motherboard form factors. All this is a really fancy way of saying size and shape. So whenever you hear the term form factor, size and shape. It's basically all it means. They come in a pretty good variety. Rectangular, square, various sizes. When you start getting down into mobile devices, they become very, very proprietary or specific to that particular device. In many cases, it's going to deal with the type of case or chassis you're using, what type of motherboard you're going to be using, and also the power supply. The most popular form factors there are the ATX, the micro ATX, and the ITX. The ITX itself is a family of all the smaller motherboards, so it's just kind of like an overarching or umbrella term for a lot of the smaller form factors that we deal with. And some of the most popular under there are the Mini, the Nano, the Pico, and the Mobile. I do have a wonderful picture for this.
So you have your standard. They do have a larger than the standard, which they use for gamers. I can't remember it's still an ATX, but I forget the acronym they use for that. So it's a little bit larger, has more expansion cards, and can run more power, more RAM capabilities as well. The ATX is a rectangular one. Typical dimensions are 12 by 9.6. Do I need to memorize this? Not typically. If you see it as a rectangular shape, it is typically your ATX, and it's slightly larger than a standard piece of paper. So for papers 8.5 by 11, this is 12 by 9.6. So if it's slightly larger than a piece of paper, it's an ATX. Then you have the micro, which is a slightly smaller version, which is square in shape. So it'll be 9 by 6 by 9 by 6. These can fit into any ATX chassis. The screw hole positions are the same as the upper parts of your ATX. So you can put a micro ATX into an ATX chassis. That is not necessarily the case in reverse, because the micro ATX chassis may not be able to accommodate an ATX. Then you start to get into the minis, which are in your microcomputers, stuff like that, and then into your mobile devices. Questions so far on this? All right. So, what determines the type of motherboard you need? Yes, Nassim.
Yeah, I want to say that this doesn't apply to the laptops, right? We talk about motherboards for the desktop.
Yeah, this is specific to desktops.
All right, thank you.
And even if we wanted to get into like servers, they have what are like the multi-socket motherboards, which they may be the size of an ATX, but you can put 2 CPUs in them, and some of the bigger ones you can actually put 4. So when you're talking about server motherboards, it's a little bit different. And one thing to take note of with regards to a server motherboard is they have a RAM bank, which is like these memory modules here. For each CPU, they have their own RAM banks. And multi-socket can either have 2 or 4. The 2 socket ones will typically be around the size of a standard ATX, but some of the more powerful servers may have 4. But that does not mean that a server cannot operate off of a single CPU. It's just they have the capability of utilizing more. Yes, George.
So just to confirm, the standard and the micro both go into desktops, and the mini is for you said phones and.
No. Mini is like, you know, like the smaller computers like we were talking about yesterday.
Oh, the microcomputers. Yeah.
Yeah.
Sorry.
So the mini goes in those. The micro and the standard can go into a standard tower.
Is there a better? I mean, is one better than the other between the standard, micro, and mini, or is it just a preference and ports available?
They have the ATX has the most capabilities. So it has the most expansion cards. So if you're looking at like 4+ expansion cards, it's definitely an ATX.
Gotcha.
You look over at the micro, there's only 2 expansion cards.
So it's
You
more
also-
just expansions, right?
Yeah, more
Variations?
expansions and more capabilities. Like you look over here, you sit there and you see, you know, you have larger RAM banks that you can use more RAM modules in on an ATX than you can on a micro ATX. So when you go smaller, you have less real estate to be able to expand, more things are incorporated, and less modification capabilities, like less ability to upgrade or add things. So good question though, I like that. Amaya.
Does motherboard can hold more than one CPU?
Some can. We just mentioned the multi-socket CPU or the multi-socket motherboard, which can hold 2 CPU chips or 4 CPU chips, but those are not typically found in desktops. Those are typically used as servers. You can use a desktop as a server, but again, if you need more power, more capability, you can get into the multi-socket ones where you have 2 to 4 CPUs.
Okay. How
Does that
about
answer the
RAM?
question?
Yes.
Okay, excellent.
What about RAM?
RAM, when you're
Yeah.
dealing with multi-socket CPUs, each CPU has its own RAM bank. So like you see here, I'll show this, I'll talk about this a little bit more when we get into when we have a better picture of the CPU, but you have a CPU here and you have 3 RAM banks. If this was a multi-socket, you'd have a CPU, 3 RAM banks, and you have another CPU and another set of 3 RAM banks. So there would be dedicated RAM banks for each CPU if you had a multi-socket. Yes, Caleb.
How often would you have to replace these? Like, just out of curiosity.
Motherboard?
Yeah.
Depends on what you're using them for. As far as them breaking to have to replace them, it's
How about
exceedingly rare.
gaming? Gaming, because you have said before, like, depending on how hot it is, it
Mhm.
like really messes up the components in your PC.
Yes,
So, like,
temperature
how-
can. Yes, go ahead.
Yeah,
I'm
so
sorry.
like how long would the lifespan of these ATX would be?
I would say like the ATX on a gaming one, if you have like a serious gamer who is using it pretty
Yeah, like
readily,
daily.
I
Yeah.
would say 3 years, 5 on the outside. So average
thank
probably
you.
3-5 years if you got a really good batch,
Right.
and it's properly maintained, probably 5 years on the outside. But by then it may be worn out, or newer technologies come out to where you want to be competitive and you want to upgrade anyway.
Yeah, that's what I have, DW. I have what looks like standard ATX, but I was just wondering because my computer goes through its paces, and I know eventually when it gets really hot, and it does,
Mhm.
I'm gonna eventually have to replace that. So
Yeah, but I mean, it could be, but the heat may not affect all components equally. So the heat may have more of an issue in the CPU and your GPU versus the motherboard. So the motherboard may still be fine, but the heat may end up harming your graphics card or something like that. So maybe an individual component, not necessarily the motherboard, but properly maintained, they'll last a good while. And it may be an issue of, I'm not competitive anymore, so I need to upgrade my stuff. So, all
Well,
right,
if you're like me, you would never work on presents.
then you can come in with the Commodore 64 and be happy. All right, so when you're looking at motherboards, if you have an existing system, this is under the assumption you have an existing system and you're replacing a motherboard. First, you need to look at what type of case you have. Make sure your motherboard's form factor or size and shape can match up with that. What kind of power supply you have. Will the power supply, will the motherboards be able to get enough power from power supply? Is the power supply robust enough to be able to handle it? The type and number of slots, what kind of expansion cards do you need for either your job or leisure use, what have you? CPU socket type, what kind of CPU are you currently using, or what kind do you want to use? Socket type is very, very specific. And remember, we were talking yesterday about the LGA, PGA. You can't cross those over. You cannot put an Intel chip into an AMD motherboard. Will not work. They won't be able to communicate. So you have to pay attention to that socket type, and we'll point it out a couple times and see if people are, can pick out real quick which type of chips go in which kind of board. The number of memory modules, how much expansion capability do you want? How much memory do you need to operate on a regular basis? The speed of the memory and the CPU, the chipsets, the bus speed on the motherboard itself, and its compatibility for plug and play. All right. So expansion slots and sockets. So right here, we have our CPU socket based on what you're seeing in the bottom of that chip. What kind of chip is that?
Land grid.
Land grid. That is absolutely correct, Stacy. Why do you say that?
It's flat.
It's flat like the land, right? And it may be difficult to see, Excellent there, Stacy. But maybe difficult to see, but if you look inside this socket here, you can see little pins sticking up out of the socket that are going to touch onto each of these little connectors, these flat connectors in the bottom of the CPU. And they will gently lay on top of it. You can't see it, but there's a little cage right here that will lay down on top of the CPU, and then you'll press down on an arm and lock it in place. Then it's called your ZIF, or zero insertion force. And that's what holds the CPU down to the motherboard so it doesn't move around if the computer gets jostled or moved or something like that.
What is a ZIF again?
ZIF, it stands for, it's ZIF, stands for zero insertion force. And you can't see it right here, but there's a little cage that sits down on top of the CPU and kind of presses it down into the motherboard. There's an arm that locks it in place. And that's what makes sure that you have a solid connection and prevents the CPU from moving so that communication can occur. All right, so RAM, here it mentions single or double inline memory modules that can be used. You lock them in here. That is your short-term volatile memory. Don't worry, we will do a deep dive on RAM this afternoon. But these work in banks. So you have what they call single channel, which means each memory module works by itself. They have dual channel, in which the RAM modules work in pairs. So two units will work as a single unit in pairs. And then even now, especially when you start getting into gaming, they have what's called triple channel, where they work in threes, and they have quad channel, where they work in fours. And that is your volatile or temporary memory for the machine. Quickly identifiable on the motherboard by these tabs on either side. And they are typically pointed in a perpendicular angle to your expansion slots. Expansion slots need to be able to point out the back of the computer. And so you don't get them confused. The RAM modules are pointed in a different direction. So it's a little easier to point them out. Questions so far? So CPU and RAM modules. We will do deep dives into each of these components as well as we go. All right. So next, we talked about this briefly yesterday, the PCI, or peripheral component interconnect. And this is where you add additional functionality to your motherboard, be it a modem, NIC, sound card. Typically on a PCI, you would not add a video card, but this is typically what they are used for. It gets into some details like the 32-bit data path, 5 volts of powers. No, you don't really need to memorize that. Just kind of have a basic understanding where that is. PCI version 2 doubled those bus speeds and speed rates and decreased the required power. I think right now, as of 2019, PCIe version 5 came out. So that is the most recent version, and then version 6 is set to come out next year. And each version, they tend to double the speed capabilities of these particular expansion slots. But this is the old school, just straight PCI. On old motherboards, they're identified because they typically are a cream color on the motherboard. So they're like a whitish, like off-white color. And in them, so you don't use the wrong version, because remember, the like version 1 used 5 volts, version 2 used 3.3. If you put a 3.3 in a 5 volt slot, you can burn out the component. In order to prevent this from happening, they actually put notches in the expansion cards. So you have a notch in a different place each time. They do this with RAM as well. With each generation or type, there is a notch that's in different locations, so you cannot use the wrong generation. It won't fit in properly. It'll just kind of teeter back and forth because that notch won't match up. It's a quick, easy check if you're not sure if that RAM module is or expansion slot is compatible. You line up, you set the card up next to it, and just look and see if that notch lines up. Questions on that? Yes, George.
So the one pictured on the left is a 3.3 volt PCI.
The one pictured on the left, so
The
this one
ones,
over
yeah,
here.
right there. Uh-huh.
Yeah, I think that is a 3.3. And then we have a 5 over here, and there's different sizes of PCI slots as well.
The picture, the image on the left, yeah, that one right there.
This
So
right
that one
here?
would be a 3.3 volt.
Yeah, I believe that is a 3.3.
Okay, cool.
Bubblecraft.
Yes, and with the memory sticks, like, doesn't it also differentiate with the way the slots are? Like the far left is the DDR2. That's how they look like. That's how the
Yep, and we have a good
separate-
graphic for that in the next, in this afternoon, where we'll show that, where the same thing with the memory modules, they move that notch around based on based on the generation of the RAM module.
Okay, cool.
So yes, you're absolutely correct on that. All right. Continuing on, we got the PCI X, which is the peripheral component interconnect extended. It was kind of a high-speed alternative for the PCI, plain PCI, but this was more in the server market. So this is not something you'd see in typical desktops. This was typically only seen in servers. In laptops, they use something called the mini PCI. So it is a much smaller version of the PCI itself, and all-in-one computers, because when you start dealing with laptops and all-in-ones, real estate is a big issue. So they need to be able to fit as much as they can in a very small space. So this is typically used on the small form factor motherboards. It's a lower power version of the PCI. And it's also designed, instead of like the original cards where they stick in and they just poke up into the tower, these slide in and then lay flat. So they're able to fit inside the laptop or all-in-one computers.
I have a quick question.
Yes, Henry.
Would the mini ones be used also in tablets as well, or would that be something small, even smaller?
In some of the higher power tablets, yeah, they might use those. In some of the more standard tablets, it's more integrated. Like most of the stuff that's they're wanting to use is already integrated into the board or the chips, rather than expanding them.
Okay, thank you.
Mm-hmm. So, as we talked about yesterday, where the PCI was not quite enough to be able to do something as robust as improve the graphics of the computer, they upgraded it. So you can see the old PCI, it's that off-white or cream color right here. They ran an upgrade to a more robust communication that would go through Northbridge, have faster, more direct communication. And this is the AGP, or accelerated graphics port. You do still see these around today, though they are not typically used for graphics cards. But the same as with your other expansion cards, you see there's a notch involved here in the slot, and it moves around based on the version, so that you cannot use an incorrect version. You do see a universal one here, which would be able to be used with the 1.5 and the 3. And it is built to accept either. Questions on this? The accelerated graphics port is typically a brown color on the motherboard itself. Although in some pictures it looks black. Yes, Ian.
What is Northbridge and Southbridge?
We will get into that in just a few slides. I love that question.
Okay.
So quick, easy way to think about it before we talk about is Northbridge is the, all the things that need to communicate quickly with the CPU go through the Northbridge. So that would be like your RAM modules, that would be your graphics cards, stuff like that go through the Northbridge. Slower communications go through the Southbridge. That'd be like your keyboard, mouse, stuff like that. Some people may think they type fast, but there's no way you're going to be typing fast enough to be able to overwhelm your computer. So slower communications go through that, but we'll talk about that a little bit in a few slides. Thank you. George. You are muted.
Sorry about that. The AGP
George?
we have pictured over there. It's so in that case, since we have a 3.3 volt key and a 1.5 volt key, would fit into just the universal port, right? It wouldn't fit into any other ones because it has both keys present, right?
Well, basically what that is like that's a universal card where it can be used in a 3 or a 5 or a universal slot.
But the one we have pictured above it, you see where it says it has both keys?
Yes, that's what I
3.3?
said. That is a card that is universal.
Oh, okay, got it. So, but which one would that actually fit into? Would it fit into?
That would fit in the first 3, any of the first 3s.
Any of the first
use
3.
It in the, you could use it in the 3.3, you could use it in the 1.5, or you could use it in the universal.
Got it, because I thought because I had both, it would only fit a universal. So, but because it's both present for the 3.3 volt and the 1.5 volt, it can actually fit into all 3.
Correct.
Got it. Thank you.
Yes, Adriel.
Is this something that is older?
But AGPs?
Yeah.
Yes, it is older. It was a bridging technology between the old PCIs and the PCIEs.
Okay.
But
so it's just something that ended up in. It's something that's been not something that's been upgraded, but it's kind of a stepping stone into what we have now for PCI.
Correct. But you will still see them out there. It's not old enough to where it's completely gone. You will still see them out there. But they will typically use them for some other purpose other than graphics cards.
Yeah.
Like they may put their NIC through it. They may put a 3D sound card through it, something like that.
Oh, so it's not necessarily like it's the port that we're really thinking about, not necessarily what you put in.
Correct.
In there. Okay.
Because these ports can be used for a multitude of things.
Yeah, I think it's because it said accelerated graphics. What I'm thinking of, like just having anything.
Yeah, and that's because that's what it was originally designed for, was to be able to upgrade the graphics, to a better step than the onboard graphics of your typical CPU or motherboard. So this was meant to upgrade that, and this was the first step on that path. And so they figured they would just name it a graphics port. But yeah, it can be used for other things as well.
All right, no problem.
All right, expansion slot sockets. Now we're entering into a more modern era, which is the expansion slots PCIe. And in this case, it stands for Express. Unlike on the SATA, where we talked about where the E in the eSATA, E stands for external. And here it is Express. This is the higher speed of the different sockets that we had. They have what are called by 1, by 4, by 8, by 16, and that is based on the size of the slot. We do have a good graphic. We'll show you what that looks like. And as we said, currently they're on version 5 of the PCIe, which came out in 2019. And then next year, version 6 should be rolling out as well. So in each generation, they tend to double the speeds. Do you need to memorize this chart? I would love to say yes to torture you, but no, you do not. The main thing is just when you're looking at it, make sure you're understanding what they're saying when you look at it, so you're able to make sense of the specs that are involved. All right. So here you can get an idea of the different sizes. So you see these little short ones here. Let me get my annotator out so we can kind of see this stuff. See these little short ones right here. So here's one, might be hard to see. Here's one. That is, those are by ones. So that is a PCIe by one. It's real short. Over here, you have a PCIe by 4. Here's an old PCI, got that off-white cream color. And then you have the more standard PCIe by 16. PCIe's tend to be either blue in color or black. And again, on gaming motherboards and PC builds and stuff like that, as they're also going for an aesthetic look, because these are also kind of like art pieces and not just functional computers. Depending on the color palette they're going for, they may change the colors of these, but just on a standard board that you would see like in an office or something like that, that is not a gaming PC, they're usually blue or black. Questions so far? So the smaller the slot, smaller the number. So PCIe by 1, by 4, by 16, and they do have a by 8, but by 8 is kind of rare, I imagine. All right, chipsets. So every motherboard has a built-in chipset, which is one or more integrated circuit chips, like we talked about, firmware, that will typically be soldered onto the board itself, that will inevitably support the CPU's ability to interface with all other peripherals that will be connected to the motherboard. We have to make sure when installing a chip, just because the chip fits in the socket does not mean that chip is compatible with that board. Or the board may require an update or an upgrade to be able to be compatible with that chipset. Sometimes you'll see, like if you look at computer builds people have done, they'll say, yes, this chipset is compatible with this board, and they'll have an exclamation point next to it, like with a caveat. And it'll say you have to be able to upgrade the board first, which means you need an older CPU to be able to talk and do the upgrade. So when you're doing builds like from scratch, this is something you really need to pay attention to, because you don't want to buy 2 CPUs just to get the one working. So always read your documentation is one of the key lessons you'll take out of this particular class. So the most common chipsets you'll come across are your Northbridge, which we just mentioned here briefly, which connects all your high-speed interfaces, your CPU, your RAM, and video, and it is located closest to the CPU. However, modern CPUs are integrating the Northbridge into the processor. So that gives it the fastest possible connection. And now they're even taking steps to integrate the Southbridge into the CPU, because in order to get things to communicate faster and work better together and all that kind of fun stuff, you have to integrate it closer and more into the circuitry. Because on a circuit board, it may not seem like it, but distance makes a huge difference. You know, when you're talking about nanoseconds, you know, where communication needs to take place, because it has to figure out every pixel that is on your screen. And you're talking high def, that's a lot of pixels. And it's got to be able to refresh these at a, you know, at a really good clip. And to be able to get those really, really crisp pictures, they need that really fast communication. And if the data has to travel a long distance, it slows it down and it almost becomes noticeable even to us, because you might start getting pixelated images, things like that, because the distance is slowing down the information. So just like in real estate, location, location, location. The best performance you can get is allowed with more integration in the CPU. So older chipsets and older motherboards, Northbridge and Southbridge on the outside will show you what that looks like. Newer ones, they're integrating it into the processor. All right. So here's kind of a logical diagram of how the CPU itself works, or the motherboard, excuse me. So you have your CPU, which is the brain, and it has direct communication with your clock generator, which we'll talk about here in a second, and your north bridge. And then as we talked about earlier, the north bridge predominantly is communicating with your memory slots where your RAM goes and your graphics card. So that would be your PCIe and AGP slots. So the things that need the fastest communication have the most direct link to the CPU. Next, we have to go to our slower items. The slower items go through the south bridge, which is also called the I/O or input-output controller hub. Through there, you would get your onboard graphics controller, which would be your integrated graphics that typically came with your motherboard. You would have your PCI bus, which is your older PCI slot. If you do have those, that'd be for your NIC cards, some sound cards, modem. If you wanted a Wi-Fi connection, like I added a Wi-Fi antenna, you could do that through there. And your hard drives, so like your IDE, which is like your old floppy drives, your SATA connections, which are your more modern hard drives, your solid state drives, your optical drives, Ethernet, audio connections, CMOS memory, which we'll get into that here in a little bit. Your flash ROM also connects through there, which is for your BIOS. That's your settings for your BIOS. And then your super input output, which is your serial, parallel, floppy disk ports. These would be your exterior ports that you would have on the back of your computer. So all of that goes through the south bridge and then goes through the north bridge and then onto the CPU. So they have a longer distance and more checkpoints to travel through versus north bridge, which has that direct connection to the CPU itself. I do encourage you to get a screenshot of this particular graphic. It is helpful in just kind of remembering how all this stuff fits together. Questions so far? All right. All right, so newer chipsets, like we just mentioned, allow the north bridge and now the south bridge to be absorbed into the CPU itself, and that increases that communication speed with the RAM and the video as well. So as of the last version, that was only the north bridge. Newer version, south bridge is starting to come in as well. So there's another version of that same graphic if you wish. All right, clock generator. How do all these components know when to talk or what speed to talk at? So each computer has its own clock generator. And it may surprise you to know that it's just a little crystal. It's a quartz crystal. Kind of like wristwatches, have that little quartz crystal that help the watch keep time accurately. And that is because quartz, when you put an electric current through it, vibrate at a consistent and predictable rate. So we were able to set the clock of the computer to this quartz crystal that's vibrating inside the computer. This is called the Physioelectric Effect. You don't really need to know that, but that is what it's called. So we use that technology on the computer so that all the devices on the computer will time their communications and everything based off of this clock. It's almost like the metronome for the motherboard. And when we start talking about RAM and stuff like that, it's almost like music. We have whole notes, half notes, eighth notes, 16th notes, and you can base all of your communication off of these speeds. All right. Now, let's talk a little bit about the basic instructions that go with your computer when you're first building it. You have the BIOS, or as we mentioned before, that is the basic input-output service, and that serves three main purposes. It basically is the data instructions and codes that enable the CPU to communicate and manage all the devices on your machine: keyboard, mouse, hard drive, speakers, memory, monitor, all that stuff. It needs to have a basic set of instructions to be able to, talk to them and use them as they are intended to be used. This is not something that just happened automatically. It really needed to be set up, and each system needs to learn how to talk to each set of devices, which is why we tend to, update drivers and stuff like that give us full functionality, but our system will come with a basic list of drivers to communicate with the most popular devices. Next, the BIOS performs a hardware initialization during the booting process, or what is called the power on self test, where it's checking to make sure everything is communicating right, all the proper components are in place and can be communicated with and are good to go. And the other thing it can do is it can change the settings of the motherboard. And that is stored in the CMOS RAM. And this includes your date and time, where you are. This includes port configurations, what is where. And then, very importantly, boot order. Where do I go look for an operating system? Do I go look in hard drive A, B, or C? Do I go looking in an optical drive? Do I need to go out over the internet and remote log in and get a desktop there? The BIOS is where all of this is set up, and it tells the system where to go so that everything boots up normally when we turn it on. Now, the settings for the BIOS are stored in essentially a flash memory. So if it loses power, all your settings are erased. Now, how do we keep power when we unplug our system, move our computers around, the power goes out, all that stuff, so we don't have to redo all of our settings every time? There's a little battery that is attached to your motherboard. It looks like a little watch battery, a little round, is it NiCad battery? And it basically feeds a trickle of power into the RAM so that there's enough power there that it does not erase. That is, and one of the easiest ways to figure out, we'll talk about this again, that your CMOS battery has died, because it does die usually after a couple years. If it dies, you'll start getting what are called date and time errors every time you turn on a computer. So every time you turn on a computer, it says, yeah, date and time not properly lined up. And if that happens every time you're turning on a computer, that means your BIOS, your CMOS battery has died and just needs to go in, open the case, and replace that little battery. It's like a 5-minute procedure. But that is one of the key indicators that your BIOS has, your BIOS battery has died and you've lost all your settings. Typically in home computers, you don't really notice this. It's just an annoying error that you have to keep going past. The other nice thing about that, or bad thing about that, is if you set up BIOS security, like a BIOS password and something like that, so that you can prevent people from updating or configuring the BIOS or even getting into the main system. When you update security settings, the way to bypass those security settings are to remove the BIOS battery and force that volatile memory reset. So you can either remove the battery, or there is a jumper, which is a little pin that you pull out and you push in, and it auto resets the BIOS. We will mention that again. You will see a question like that on the test, just to have it in your memory. But that being said, if you work in a big company and you don't want employees going in and messing around with the BIOS, and you set up the password, how do you prevent them from doing this and going in and changing your settings? This is why in many computers on desktops, you see that little loop to put a padlock on and lock the case. So in IT, we will talk about it as we go along. Security is not always digital. There is a physical aspect to security when it comes to your systems, because the general rule is if they have physical access to your system, they own your system. They can pretty much do whatever they want at that point. Babukar.
Yes, about the BIOS. I used to think back in the days that once you password protect your BIOS, then your computer is 100% safe. But then I came to realize that you can bypass the BIOS password, by moving the jumper to the 2 and 3, and then after that go over the settings, restart the computer, and take it back to jumper 1 or whatever. So I'm like, okay, so I used to think like it can really protect your computer from anybody breaking into it, but
yeah, unfortunately, with regards to security, there is no magic bullet. There is no one tried and true perfect thing that you can implement that makes your systems impenetrable. It's all about layers. You have to layer your security, but we will talk about security in pretty good depth towards the end of the cohort. All right, any questions so far with regards to BIOS or CMOS RAM? Yes, Caitlin.
Yeah, real quick. You said when the batteries died, you hear what happens when the battery dies?
So when the battery dies, whenever you restart your computer,
Mm-hmm.
you'll get like a beep, and it'll say like date and time error.
Okay.
And basically, because what's happened is it's not able to maintain the current date and time in the system because the battery's dead and it lost power. So it resets the memory every time.
Okay.
You can still use the computer after that, but it's an indicator that all your BIOS security and settings have been erased.
Okay.
Now this becomes a problem if like it has to go out to the internet to pull up its operating system. Like if you operate point of sale machines and the operating system is actually on a server versus in the actual computer, then it won't be able to boot up at all because it doesn't know where to look. If the operating system is already on your computer, then it just goes right to that and you're fine. So typically for home use, this is rarely an issue or just a minor annoyance, but in a office setting, like in a retail environment, or something like that, it can shut down operations because, or for that computer, because it can't communicate with its main server.
Okay.
All right. Any other questions? All right. This is basically what that CMOS battery looks like. Like I said, it's a little watch battery. If you're on site in an organization, I highly encourage you to have about 5 or 10 of these in your tool bag. They cost 25, 50 cents a battery if you buy them in bulk. You buy like 10 or 20 of them at a time. So you just keep a few of them in your case. You swap them out if you have a problem, or if you're doing maintenance on a machine, you notice the machine hasn't been opened or maintained, because you usually will have logs of this. In about 2 years or so, you might go ahead and just swap out the CMOS battery so it's not a problem later as part of your basic maintenance if you go in and clean out a computer every couple of years. So, and it also gives you a kind of a quick view of the firmware chip that stores your BIOS. All right. So BIOS is an older set of instructions. They have updated this to a newer version because the BIOS could only handle smaller drives and systems and stuff like that. So they needed to update to something a little more robust, which is now the Unified Extensible Firmware Interface. If you ever have to go into quote unquote the BIOS, you still have people refer to it as BIOS. If you ever have to go into it, immediately when you go in and look at it, you will know which one you are dealing with, because old school BIOS looks like Windows 3.0. It looks very old and you can't use a mouse. It's arrow keys only to navigate. So right there, that'll tell you you are dealing with a BIOS. If you can use a mouse, or it has, some of them have some pretty user interfaces now look like this, you know, where you can sit there, you can set your fan speeds, you can do a ton of really cool stuff. You can use your mouse to navigate. There's actual graphics involved. This is absolutely a UEFI. I have a picture of a BIOS, but it's a little bit later in the presentation. But this is the Unified Extensible Firmware Interface. So this allows you to have drives larger than 2.2 terabytes. BIOS couldn't handle that. Supports 32-bit or 64-bit architecture on chips. And within it, in the configuration, like we just talked about, they allow graphical interfaces rather than the old school 8-bit interface that you will see in the old BIOS. But again, I have a picture of that. I'll show you that here in a minute. So any questions with regards to that? Yes, Babukar.
Like with the BIOS setting, doesn't the screen turn to like gray, blue or black screen?
Well, it's gray. It's like blue and gray typically.
Blue and gray. Okay.
And then if you again, but there are UEFIs that look like that too. But but typical rule, one, it'll tell you at the top, and they'll give you a version of your BIOS too, in the settings. But it'll tell you if it's a UEFI or BIOS. But if you can use your mouse, it is absolutely a UEFI.
Yes, because with the BIOS you cannot use a mouse.
You cannot. It's arrows to navigate. So if you can use your mouse, it absolutely is a UEFI. All right, we will come back to BIOS, and I know what each of you guys are thinking out there. Man, that sounds kind of scary. It's kind of interesting. Is there any possible way we can work with something like this and get our hands in there and practice and do all this? Well, you're in luck. There's a test out lab for this, where you'll be able to go in, play around, and mess around with the BIOS and the UEFI. Yes, Adriel.
We're gonna get the flash BIOS.
I think they do have a lab for flashing BIOS. I love that you brought that up.
It's gonna be funny.
Yeah,
I've made a lot of mistakes.
So you have a few bricks laying around the house?
Yes, bricks is definitely what I would like to call them. Very heavy paperweights, you know.
Yep, and expensive ones too.
Extreme. Well, they were Windows XP was a really good operating system, so I don't want to say that.
I agree.
It's very user friendly. But yeah, very big bricks.
Yep. We will talk about that in just a moment. Babukar.
Yeah, about flashing BIOS. The first time I heard it was in 2005. That's when I first got my laptop, and then I had a BIOS password, and I forgot the password. So I took it to a technician, and this guy had the computer with him for like a month. Don't know what to do with it. And then he came back and told me, "Well, I don't know how to remove this password, but you're gonna have to flash the BIOS." I said, "How do I flash the BIOS?" So it was very scary. I said, "How do I do that? I'm gonna break my computer." So I had to take
all he literally needed to do was pull the CMOS battery out.
Exactly, and I didn't know even how to do it until recently, like 5-6 years ago. So I was like, okay, flashing BIOS, that's gonna break your computer.
Yeah. Wow. Yeah. Not all technicians are created equal. You will learn this as you go. My old partner Marvin, before he got into this program, like when he was in college, he actually worked at Circuit City. Anybody who's been around long enough to have ever dealt with Circuit City, they were an absolute nightmare, and their techs really did not know what was going on. They basically had one trick up their sleeve, which was formatting the hard drive. So basically anything is wrong, they formatted the hard drive. That was their one and only trick that they had. And so we jokingly started referring to this as the King method. His last name is Marvin King. So, when all else fails, perform the King method.
Format and restart.
Basically, that's what it is. And he was like, it was like 49.97 or something like that. He's like, we could try to repair it, but formatting, this is the one true guaranteed way to make sure that it's fixed. So, we kind of laughed about that one a little bit, but we'll talk about that as we go. Did you have another question, Babacar?
No, sorry, my hand was still raised.
Not a problem. Adria?
I was gonna say, I was surprised when you had said that removing the CMOS battery,
Mm-hmm.
you could basically bypass the BIOS password.
Yep. Any
Or
BIOS security that is in place.
Yeah, in general, like that, it's surprising, even if there's a problem with your password in general, how easy it is to fix something, like by literally turning it off and turning it back on.
Mm-hmm.
Essentially.
Yes. That does fix a lot of issues.
I guess that's why backing up stuff is so important.
Yes.
Because it's like
Very much so.
maybe just having the computer figure it out on its own is better than us doing something about it.
Well, I mean, it depends on the sensitivity of the data on there. Like sometimes you don't want to go to the nuclear option of formatting your hard drive. There's stuff on there that you need to salvage.
Yeah.
So there is that. Casey.
Sorry, I feel really slow today, guys.
No worries.
So essentially what Andrea was just saying, that the easiest way is just literally pull out the BIOS battery to reset it.
Yeah, if there is a BIOS security in place, like it's requiring a BIOS password, you just remove the battery and it resets the settings.
Okay, cool.
And
all right, thank you.
That is one way. The other way is called a jumper, and there's a little pin in the motherboard that you can pull out and you poke it down in a hole next to the battery and it resets as well. So you may get asked, there are two ways to reset the BIOS, and that is remove the battery or use the jumper.
Okay, thank you. I forgot about the jumper one.
Yeah, the jumper is kind of like the button on the back of a PS4 controller.
Yeah.
It's
reset the
kind of like
settings.
that. Yeah, you just press the thing on the back and it's just simple. Usually there's literally a button on it on the motherboards now.
So it's
It
like
just
an
says
actual
stop.
button, or is it like when you pull off the button, you see like a little rubbery piece like underneath the actual button? Is that what you're talking about?
What it is it's like a little hole in the motherboard and you use a pin to poke it, and they have a little pin next to it, which is called the jumper.
Okay. No, I was talking about the PS4 thing you said, or the controller.
Oh, it's it's an actual button on the inside of that.
Got it.
But it's the same premise. Like you literally sticking something in there and it just resets something.
Got it. Thanks, man.
And
All right,
to,
go ahead.
Real quick, just a heads up, like if you guys ever used a school computer or something like that, you notice that they have padlocks on the case, and that's one of the reasons, right? So that you can't get into the thing and just pull out the CMOS, and then hack into it. So
All right, and we had a question in chat asking about how to access the BIOS, and how you get there is there is an option where you can boot into it, which we will get into it a little bit later. And then the other one is as you are booting up, depending on the computer model you have, it'll either be delete, F8, or F2. It all depends on the computer model you have, version you have, how you will get into the BIOS. On test out, it's typically delete, if I remember correctly. So delete is typically how you get into the BIOS and test out when you do a reboot in a simulation. Did you have another question, Babacar?
Yes, regarding the CMOS battery thing, I've tried that with a BIOS password and it didn't fix the problem. So the most effective way, I think, is the
jumper.
The jumper, yeah, the jumper will definitely.
Was this on a laptop?
Yeah, it was on a laptop.
Was the battery still installed?
Oh, the battery. I removed the battery and then.
No. The main battery of the computer.
Of the laptop itself. Or
yeah.
The CMOS battery. The main
battery of the computer.
Yes, I disconnected the power supply, removed the battery, and then take the CMOS battery off, let it sit for like 10-15 minutes, reinstall everything, but it didn't come off. But when I tried the jumper thing, that one took it off, because it takes you back to the settings, and then through the settings you can take the steps by clearing the password and all that, and then saving your work, and then it will just take it off. But CMOS, I don't know, it might work sometime, but I tried it, but it didn't.
Interesting. I hadn't come across it where the CMOS did not work, but yeah, those are the two methods that you typically use: remove the battery or use the jumper. So, yes, Crystal.
Good morning, everyone. I wanted to ask you, you know how is replacing this battery, is this something that could possibly wipe out your machine? And you have to go back and redo all of your settings and stuff like that?
Well, you will
Or-
have to do your you will have to redo your BIOS settings, yes.
Uh-huh.
But everything else, like your normal operating system settings and all that stuff, that shouldn't be touched.
Okay.
But that you may have to set up your boot order. You may have to, you know, update your BIOS version or something like that. Stuff like that. But it's not going to redo everything on your computer, no.
Okay, thank you.
Mhm. Good question. All right. So a little bit beyond. Oh, I'm sorry, y'all. Let's take a 10-minute break. Let me pause the recording here. Resume. So we talked about the BIOS. We talked about, you know, basic structure of the motherboards, kind of how it, you know, information goes through it logically, how things connect. Well, now we got to talk about how we connect things to the motherboard itself, outside of sockets. So we have basic connectors that we need to operate from, and interfaces on the boards that we operate with or interact with. So first and foremost, you have some fan connectors here. You got your 2, your 3, and your 4. Fun question. I have a 4-pin connector like this, but on my board, it only has 3 pins for a fan. What do I do?
Plug it in
Why?
because it can still work. One
Still
of them
work.
is,
What changes?
I think one of them would
Voltage?
be
Or the wattage? changes?
no,
Not the voltage.
it's a controller. So basically, you'd be able to alternate it. You would be able to control how much power you put into the fan,
Which would
so
do what with the fan?
speed it up or slow it down.
There you go.
So then it runs that one thing.
Yes. So there's no funky adapter needed. You don't have to go out and buy a new fan. If it's a 4-pin fan connector and you only have 3 pins on the board, you plug it in. Because the 4th pin, all it controls is the speed of the fan. So the fan will either be all the way on or all the way off. You're still getting cooling. It's just not adjusting the speed. Excellent, Adria. Yes, Brianna.
So with the fan connector, it doesn't matter how many slots are in it.
Well, they specifically mentioned the 3 to 4 pin.
So
if you have
the
it-
3 could fit into 4, but is that the only interchangeable one?
That's typically the only one you would come across. Yeah.
Oh,
2
okay.
pins are exceedingly rare at this point. But
Okay.
the 3 and the 4 is the most common.
And if it has 4 slots in it, does that mean the fan will be faster or slower?
No, it just means you can adjust the speed. So you would have like a low, medium, high setting versus just extreme high all the time.
Okay.
So that 4th pin just controls the speed of the fan. First 3 pins will tell you turn it on and off, all that kind of stuff.
Okay.
All right. Next to that, we have what is called our 4-pin Molex, which Molex is the type of plastic. And this is typically used as a power supply for drives, things like that. And then one of our most important right here is our P1 power supply, which is either a 24-pin or 20 plus 4. And when we say 20 plus 4, what it is they have a 20-pin connector, and then there's a 4-pin that can either be attached to the connector or it can actually disconnect from it. So that is a P1 24-pin connector or 20 plus 4. That is the primary power supply for your motherboard. It's the biggest plug on the board. It's easy to spot. Yes, Galen.
What's the name of the second one again for me, please?
That is the 4-pin Molex, M-O-L-E-X, Molex.
Thank you.
Then you have the most frustrating of all connectors. You have your front panel connectors. It's these tiny little connectors that allow your motherboard to connect to the front panel of your chassis, which allows you to push the power button and something happen, plug in or see little blinking lights when things are talking, hear little beeping sounds when you know stuff's working. And these are less intuitive when you plug them in. So you say you have, what is it, 5 of these here? They would all fit in this little series of pins right here. And it looks like that would be a single connector that would plug down into it. But no, it is all your front panel connectors fit on specific pins. How would I know which of these connectors go to which pins? There's 2 ways we can find out.
Do you follow the colors?
Well, colors don't necessarily work. I mean, look, all my connectors are black. If I had a gaming computer, all the wires would be black too, or yellow or orange or neon, you know, but that's a good guess. I mean, good guess. So there's two places. So what?
Google it. I don't know.
The amount of pins it has. You have a number at the bottom of it. I don't know.
Well, what I'm saying is how do I know on which pins does each connector sit? Where do I go? Brianna?
That's a good question.
I'm just guessing, but do you read what it says and then it matches on the I keep calling it microchip.
So
the motherboard says it, I think.
Yes. So if you look, that's excellent. That is one of them. So right here on the boards, it will actually tell you, it's a roadmap right on the motherboard itself. It tells you exactly what is right there and what goes there. So you can look there. That is one place you can look. Adriel, where's the other place we look?
A motherboard manual.
Which is exactly what he was just talking about. You always want to keep, no matter what, the motherboard manual. Always refer to the documentation. It will tell you what to go. You will see a schematic in there, and it tells you where to plug everything in.
Some mistakes you only have to make once.
That is true. So front panel connectors. All right, IDE. This is what is called a Sata connector, P-A-T-A, not to be confused with SATA. And this is what you would typically hook up floppy drives, old CD-ROMs, DVD-ROMs, and some hard drives. And the cable that hooks up to this looks like a big flat ribbon. We will show you a picture of it. So it's a big, wide, flat, it looks like a big piece of tape kind of sticking through there. And it is a Sata connector, and it plugs into either they either call this an IDE or a floppy drive connector. So it's the 2 words they'll use for that. Questions so far?
Kelly, what do IDE
Yes.
stand for? And then you said it's not
IDE.
SATA.
So IDE, I can't remember the exact acronym for that.
Oh, it's cool. I thought you said it, but I missed it.
No.
So you said not the SATA plugs into it, the PATA, P-A-T-A?
Yeah, PATA, P-A-T-A. So IDE, it's an older technology you won't see. It's integrated drive electronics is what IDE stands for. So that will either be called an IDE or a floppy drive connector. And PATA is Parallel Advanced Technology Attachment, I believe. Parallel advanced technology attachment, yeah. And then SATA is serial advanced technology attachment. So this would be for your PATA, your SATAs. And make sure I got my annotator. SATAs are easy to recognize because they have an L-shape connection. So that little connector inside makes an L. You can even see it on this bottom one right here. If you look, there's that L shape you can make out right there. And that is your SATA. Off to the side of our front panel connectors right here, we have these little pins that you see sticking up, and that is your USB 2.0 connector. So USB 2.0 connector, you should have a few of these on your board that you can hook up to. And thankfully, if you look right there, you can see it written on the motherboard. There is a map. Although on the test, they're going to blur that out so you won't have it. So you need to have a general idea of what it looks like and where it's located. Yes, Crystal.
When you say SATA, you mean S as in Sam, A, T like Tom, A, right?
Yes.
Okay, thank you.
They don't have the A there. So questions on this so far? Yes, Artez. Yes, we will show USB 3.0 as well.
Do all motherboards come with this little map out
on the board? Yes, typically they, I haven't seen one that did not come with it. That's not to say that they don't exist, but the rule is it's typically there. That doesn't mean there is not an exception out there.
But the ideal way to find out where these things are connected is to read the
You need to look, well, part of it is know what the stuff looks like. So when you're hooking it up, you know where to go. That's one of the fastest ways, but you'll get practice with that, don't worry. The other is there's a map on your board if you're working on one in real life, and it tells you where everything is. That's 2. 3 is the manual that we kept in a safety deposit box so we never lost it for our motherboard. Any other questions? This is not all the connectors you know. This is just kind of introducing you to some of them. Yes, Nassim.
When you're servicing someone else's computer, eventually, not necessarily you will have the manual and booklet from the computer and motherboard. So
Correct.
you have to rely on your knowledge.
Or again, they have the map there and ultimate fail-safe. Try to find the manual online. But yes, listen, but yeah, we do need to know what the stuff looks like so that we can quickly work, because we don't want to be hunting all over every time. But I promise you, you will get the practice. And it will start to become second nature for you. All right. I/O, or input-output interfaces, that you'll see on the back of a computer. Obviously, some of these are old, but you still will come across them on a pretty regular basis at this point. So we have our USB bank over here. This is USB 2.0. How do we know it's 2.0 other than they're telling us? What is the quick indicator that this is a 2.0 USB?
The color.
The color. They have that flash thingy.
The color. Mm-hmm. So USB 2.0 is what color?
Blue.
Black. 3.0 is what color?
Blue.
3 is
blue. All right, so we have yet another USB bank over here. USB 3.0, that gives us that fun blue color. All right, up here we have our network connection, which we will learn later has an RJ45 connector. That is your typical network connection. Over here, we have our DVI connector, which there are a couple different versions of that. which we will talk about and we will get more practice with, which is a monitor cable. Below that is one many of us are familiar with if we've ever hooked up a TV, and that is the HDMI connector, which can be used for your monitor. Beautiful thing about the HDMI connector, that was the first one that allowed to push video and sound. And then over here we have the display port, which almost looks like a HDMI, except it's flat on one side. So on one side it has a curve, the other side it is flat. And that is our display port. And then we have our audio connections over here, which would be our left and right audio, our microphone, speakers, and then the all-important fiber audio. And then on the lower picture here, we can see the two red connectors, which are eSATA ports or external SATA ports. Questions so far?
Can you repeat the last one? The last two?
So last one I had was the square one, which is the fiber optic audio, or SPDIF. And then down here, you have these two little red connectors here, which is your eSATA, which would use for hooking up hard drives, external hard drives. So and the E stands for external.
Okay, thank you.
Mm-hmm. All right.
Kelly, can you go back to that slide so I could take a quick screenshot?
Yep. There you go.
Got it. Thank you.
No worries. Okay. So basic geography of a motherboard. A lot of these components you need to be able to kind of pick out right off the bat. We will get practice. You will work with these on a regular basis. You will be quizzed on this. You will have jam boards to work on this. So it will come second nature. So we can take a quick walk through. You have that big open socket right here, which is where our CPU socket is. If we see a big fan in the middle of the motherboard, that is the cooling fan for the CPU. So the CPU resides underneath that. CPU fan typically plugs in right next to it. You'll see a 3 or 4 pin connector somewhere around the CPU socket, and that's where it gets plugged in. Over here is that big 20 pin connector that we talked about before, your P1 power connector. We have 2 long slots here that have those tabs on the side that we talked about earlier. Those tabs are typically an indicator of where your memory modules or RAM banks are. Behind that, on this board, you have 2 IDE slots that can be either for floppy drives or older hard drives. And this giant heat sink that is next to the CPU is our north bridge. On older motherboards, the largest heat sink you see on the motherboard next to the CPU, that's your north bridge every time. Newer motherboards, as we said, north and south bridge are being integrated into the CPU, so you do not see that as much. But older motherboards, the largest heat sink next to the CPU is your north bridge. All right, here we have a brown connector. It's a little hard with the color of this slide. That is your AGP or accelerated graphics port. Southbridge is in the back over here. It's the second largest chipset outside of the CPU. And then you have our PCI slots. Then we just talked about our input-output ports.
Kelly, how does the North Bridge look?
North bridge right here. See all these little metal fins sticking up out of the computer?
Okay.
How does it
Thank
look
you.
or how does it work?
No, how does it look? Yeah, I see it
So
now.
right here, this is that passive heat sink that we talked about. It has these little metal fins sticking up there to help it cool. The largest one next to the CPU is typically your Northbridge.
Thank you.
All right, for all you wonderful people with your cameras off, we get to walk through the motherboard here a little bit. Oh, I see them coming on quickly. See here, Sumaya, can you please tell us what letter A is? Right here. What is letter A? What does that indicate on the motherboard? Sumaya? All right. Ume, can you tell us what A is, please?
It is PCI.
It absolutely is PCI.
But I don't know what is PCI because I was looking at it as PCI. I was wondering what is PCI.
Yes,
And,
that one right there is the PCI, and that is the standard size for a PCI.
and what is the PCI?
That is where we would install our expansion cards, right?
All right. Okay.
Mm-hmm.
And what is expansion card? Sorry.
Don't worry. I have recorded the session, so you'll be able to go back and look at it as well.
All right.
But yeah, it's like sound cards, video cards, things like that. All right. Adonis, can you please tell us what B is? Here, B.
Is that a PCIe slot?
PCIe, can you give me a little more data? It's a short one. I'll give you a hint. It's a small one. It's short. So what would we say?
A mini PCIe?
Not a
Or is
mini.
that- Ah,
Not a mini, but you're, I mean,
Micro?
you're close.
is that not it?
Yeah. PCI, that's A. This would be a
Feel free to give him some
PCI
help in the chat, guys. Give him help in the
Is it
chat.
X?
E. That's part of it.
Or
so
4.
PCI by
2 or 4. I don't know.
by 1.
Oh wait,
Oh yeah.
no,
so by
1.
one.
Crap.
PCIe by 1.
Damn.
Nice, Stacy.
I was
All
like,
right. All right, so here we go. So C. Shamel, can you tell us what C is? This long blue thing right here. Shamel, you there?
I'm here.
Okay. Can you tell me what C is? This long blue one right here?
I don't remember.
You want to phone a friend?
Yeah, I'm gonna have to phone a friend.
All right.
Steven?
I'm gonna take like a, because I had a little trouble looking at this too. Is this, because I'm thinking about the color, is this
I wasn't sure.
the DRAM memory slot? Is it a color?
Not, it's not the RAM, but we
It
did
was-
specifically mention
it
it's
was
either,
a SATA,
typically either
right?
blue or black. It's either blue
Oh,
or
it's
black.
the
It was SATA?
AGP slot.
Not that, not AGP.
Oh, so I don't know.
You're getting closer. You're getting closer.
I'm not sure.
The Madison.
Is it ID? Oh, sorry.
Yeah,
problem,
I was
okay.
thinking this is the IDE.
Not the IDE.
Is it the ACP?
Not the ACP.
Got a lot of acronyms.
I know. There's roughly about 1,000. Don't worry about it.
At least I'm not alone here.
Yeah, this one's tough for me.
Stacy got it. Stacy got it in chat.
Stacy's got it. PCIe.
Oh,
The
okay.
Express PCIe. Because remember, you have the old ones, which is that cream
Oh,
color.
right,
That's
and
the
it's
old
blue or
PCI.
black.
If they're small, even if they're cream color, those are still Express ones, but they're either by 1, by 4, by 8. And then
Okay.
the big ones are the blue and black ones, which are your PCI Express by 16. Up here, this would be up here, this would be the back of the computer. That's the direction of the board. So all of these Express cards would be able to poke out the back of the computer so you could hook up additional stuff. So that would be the alignment of all your PCIe's. Remember, this is the first time a lot of y'all are seeing this. So like, it's okay to get it wrong. It really is.
You said
All right.
PCI 16 are blue or black in color?
They're typically blue or black, yes. That's excluding gamer boards, which are going to be more geared towards aesthetics with regards to color. Standard boards, they're either blue or black.
So is that a lowercase e or
Yes.
an uppercase e?
Lowercase e.
Oh.
So PCI lowercase e. Please excuse my horrible handwriting. It only gets worse as we go along.
You should have been a doctor.
I hear that. I wouldn't mind the paycheck though.
Is B also PCI?
B is PCIe by 1. So PCIe X 1. So PCIe by 1. Did you have
So
another
what's
question?
the difference?
The size and capability. So this is going to have a smaller bus speed than the larger Express one. It's not going to have as many connections to communicate to the CPU with. So it's going to be slower, but it has a smaller footprint. So devices like a NIC card may not take up a lot of space, and you can use them in the by ones. All right. Now, if I had a NIC card that was meant for a PCIe by 1, and I didn't have a PCIe by 1 slot, but I had a few of these, well, could I put it in there? Could I take one that was meant to go in this little one and put it in this big by 16 one? Okay, we got a no in the gallery.
I think so because of the wedge in between it.
So yeah, the notch is in that same place, right?
Yeah.
Excellent, Ramon. So that notch is in the same place. So you actually can, if I had a NIC card that was meant for a PCIe by 1, I can put it in a 16 if I don't have a by 1 slot. That's called up socketing.
I thought you were talking about A and B instead of B and C.
Ah, my apologies.
Yeah.
I'll try to be more clear in the future. So there's a PCIe by 1. So it's this little one right here. And I only have the PCIe by 16s.
Quick question. Would the PCIe 16 or all the PCIes, would they always be perpendicular to item F?
Yes, because item F is our RAM bank. So that is going to be perpendicular. So they're not going the same direction.
Okay, thank you.
PCIe version 2 is PCIe X 1.
Can you repeat
No,
that?
by 1 is it? Yeah.
By 1.
By
Sorry.
1. That has to do with the length, not the version. That has to do with the length of it. So by 1, by 4, by 8, by 16 has to do with how long it is, not what version it is.
Like, you know how you say a 2x4? I can't remember his name.
Which ironically is not 2 by 4.
Yeah, but I was just letting him know that the X means by. You know what I'm saying? I was trying to.
There's a lot I recognize that we went through, but did we go through D? D looks like it's just.
No,
in
we
front
haven't.
of
We
me.
haven't gotten to D yet. We have not gotten to D yet. Sorry.
Okay, all right. So I was like, what? Did I miss this? Am I like? Okay.
All right. So since you brought that one up, Casey, can you tell us what D is?
That's what I'm asking you.
I know. Well, I mean, you're already here.
If I have to guess, it's by this CPU
Okay.
and it's Northbridge, so it's got to be something quick.
Well, is it? Do the connectors look similar to this right here?
Oh yeah, so it's a power power
So,
grid or whatever.
Based on where it is, what do you think it might support?
Can I call on someone?
Yeah, give it a shot.
All right, I can call on Eric. His hand has been raised a while.
Go for it, Eric.
I think that's I'm pretty sure that's the CPU connector, CPU power connector, right?
I'm pretty sure you are correct, sir. That is the CPU power. It's got the big posts like you would see over in this power supply, but it's right there next to the CPU. And there it would either be a 4-pin, a 6-pin, or an 8-pin. Because the more modern processors need more power than just the motherboard would provide. So there's an additional power supply just for the CPU.
Yeah.
Excellent, Eric. Thank you.
Thank you.
All right. Let's go for an easy one here. Well, I mean, maybe or maybe not. Still the first time you're seeing it. Cynthia, can you tell us what E is? E, this big box right over here. What is that?
Oh my gosh. I don't know. Is it a CPU?
Oh, is it?
Or a motherboard? I'm
No, I
sorry.
mean, it's on the motherboard. No, I mean,
Oh, it's on the motherboard. Okay.
it is the CPU. I just wanted to hear it with more confidence. Yes, it's the CPU. Yes, you are absolutely correct, Cynthia.
Okay. This is all new to me, because I'm just doing my best.
That's fine. You're doing great. You're doing great.
All right. Thanks.
All right. Moving on to F. These orange and red right here. Ian, can you tell us what we're looking at?
Hold up, Kelly. Are we gonna stick with CPU or CPU socket?
Technically, it is the CPU socket, yes.
Yeah.
But that is where the CPU goes. So as this was our first pass, I was going with that.
DW, we are not in the computer science class. Only you are. I'm just kidding.
All right. I was just trying to give you the right information, so when I give you a question on it tomorrow in your Kahoot, you're not like, hey, you're tricking me.
I respect
Thank
that. I respect that. So, Ian, can you tell us what F is, please? F is in Frank. That's that yellow and orange right here.
Is that the what's it called? The memory. It's called the memory something. I can't. It's on the tip of my tongue.
You're knocking on the right door.
Yeah. Was it the one second. I have it in my notes.
No problem. You had a bunch of friends trying to help you out in chat, by the way.
Okay, I'll call on someone. I'll call on Hex then.
Galen?
Yep.
P1 power supply?
It's not the P1 power. It's the orange. We're talking about the yellow and orange right here. Yellow and red.
Wait, oh, yellow and red. Oh, my fault. I'm sorry.
No problem. Not a problem.
Hold on one second.
SK, can you tell us?
Is that the RAM memory slot?
Now it is absolutely the RAM memory slots or memory bank. As where we would put our virtual memory for the computer. And remember, it is always perpendicular to your expansion cards. The expansion cards point out the back of the computer. The RAM memory is perpendicular to that, but it's usually close to be able to close to the CPU in order to better support it. Excellent. All right, G. Here, Lincoln, can you help us with G, please?
I think that's the power supply.
Power supply, you are absolutely correct. That is our P1 power supply. How many pins? Anybody?
24.
20 by 4, 20 plus 4.
20, 20 plus 4, 24.
Right.
All correct answers, yes. Based on the motherboard that you have. Excellent, excellent. Let's see
I
here.
was gonna say, so that's the same as because I was just looking at another money motherboard. That's 20 pin power connector. Is that the same thing?
Yeah, 20 pin power connector. That is the same thing.
Okay. Cool.
That is the main rail that comes off of your power supply and hooks up there. Excellent. So we got here. DeWitt, can you please tell us what H is? Medina, you are on deck for I once DeWitt has H.
I think I can't guess, but I know J. I didn't know H.
So H right here. It's hard to see. It looks a lot like K. It's just a
Oh yeah,
different
it is for it connects a hard disk, a floppy
Okay.
disk with
Yes.
the
So a floppy disk connector would be a acceptable answer for this.
Yeah.
What's the other one? Anybody? Thank you, DeWitt. That was excellent.
IDE.
Excellent. Who said that?
Artez.
Artez. Nice work, sir. IDE or floppy connector. All right, Medina, can you tell us what I is, please?
I'm not sure about I.
Right here. It's got 4 little tiny pins sticking up. Hard to see. You have a few of them on the board. You have one of them right here, one right here. Helps your computer cool down a little bit.
Oh, cooling fan.
Fan, excellent. So that is a 4-pin fan connector. Excellent, Medina. All right, Eric, since you seem so excited, how about Jay? Over here, these yellow things.
I'm pretty sure that's the SATA connectors for your
That is
drives.
a SATA connectors. What's one quick indicator that that is a SATA in the shape of it?
Well, it has that little L at the end inside of the connector, as well. It has like 6 to hook up multiple drives.
Excellent. So you have 6 different drives you can hook up through here, and they have that little L-shaped connector. Thank you, Eric.
You're welcome.
Good job. All right, K. Crystal, got your hand up. You can help us with K, please. Yes. You're good.
I was just talking about the indicator for the last one, Kelly. I wasn't trying to answer.
You're good. It's similar. It's very similar to H. Give it a shot. Give it a shot. Don't be afraid to get it wrong. It looks just like H, but it's a different color.
I know. I'm gonna have to phone a friend, man.
Okay. You want to give it just a guess off the top of your head first? What might we hook up to it?
Is it
It's right
two
next-
things or one big thing?
Well, this is the green is one big thing. That is one big
thing, right?
connector.
Okay, yeah, so with H, it's an IDE or floppy drive thing.
Yes.
So with this one, maybe a game card slot?
No, but it's the exact same thing as H, it's just in a different location.
Oh, so
So it
it's
is a floppy or IDE, so you have.
Oh,
the
it's
information.
IDE also.
Yes, yes, it's IDE or floppy.
Robin put in there KIDE for HDD.
Yes, hard disk drives.
Okay, thank you.
Mm-hmm. Problem here. We haven't talked to you in a while here. Devin, can you please tell us what L is? L as in Larry. It's on the bottom left-hand side over here. No idea? You don't want to give it a guess? I'll give you a hint. We talked about it earlier in the presentation. We said it was one of the most frustrating things on the motherboard.
Oh.
Do it. Do you have it? It is connections. Yeah. Okay. You getting some hints? Joseph, bring us home.
Is it the front panel connection?
It absolutely is the front panel connections. Excellent, excellent, excellent. All right, we have two more. Rena, can you please tell us what M as in Michael is? It's right here, this little yellow box right there.
Is it the is it the USB connector?
You are absolutely correct. Excellent work. So right next to your front panel connectors, you will usually have two USB connectors. So we got one here and one here. That is 2.0. 3.0 is going to be a much bigger connection. They don't have one on this motherboard, but you will get multiple opportunities to see them and work with them. Yellow, on this motherboard, it's just easier to see, I guess. So the blue and black is typically that's the exterior. What you see on the outside of the computer is blue or black. So that's the connection on the outside. On the motherboard, it's going to be a little different. Not a problem, Devin. All right, finally, N as in Nancy, this silvery round thing right here. Amaya, can you please tell me what we are looking at?
Battery connector.
It is a battery. What would we use that battery for? Hold settings for the computer, the motherboard itself, so we don't lose them.
To start the computer.
Unfortunately, no, it doesn't have enough power to do that. It just provides a trickle of power so we don't lose settings and instructions for the motherboard. Getting a lot of help in chat, by the way.
Okay. To set up the BIOS.
Yeah, for CMOS, it's your CMOS battery that powers the settings for the BIOS. So CMOS battery.
Excuse me, Kelly. I'm sorry.
Excellent work. Yes, Artez.
See, you got your hand up, bro. But can you tell me what CMOS mean? My fault.
CMOS, what it stands for?
What it stands for? Yes, I'm over here writing CMOS. Like the C.
It's complementary metal oxide semiconductor. If you really want to remember it, but I promise you, you will never be asked that. In fact, this was the first time I had been asked what that particular acronym meant.
Forget it. I'm gonna just use CMOS like the one.
I highly recommend that. Just use CMOS. Yes, George.
Yeah, I'm not gonna lie, I got a lot of these wrong. Is there another slide next that can show us exactly what's labeled so I can study tonight?
Take a screenshot of this one real quick.
I got them. I'm literally doing it right now to give it to them.
Cool, thank you.
Okay. And
Yeah, I totally got some wrong.
and you will see this very picture multiple times throughout this course and even in your nightmares. So you will have multiple opportunities to work with it.
Yeah, I was just literally like writing it like a screenshot and putting text on top of them so I don't forget. But I'm glad that DW is gonna send us that too, because I definitely need that.
There is this, which is the key to it. But again, that is also in the student page slides that we did, that we put in Slack for all of you. So remember, we do give you guys each a copy of the presentation as well. So we feel, yes, Nassim.
The fan that goes on the CPU, where does it plug in?
It typically plugs in close to the CPU itself. I believe on this motherboard right here, it is right there.
Okay. Thanks.
Because you have multiple fan connectors throughout your motherboards typically. Because you have one for the case fans, so you have a front fan, rear fans, you have a CPU fans, stuff like that. So there will be multiple fans throughout that you will hook up on a regular basis. Adriel, did you have a question?
Yeah, it was just this specific motherboard it's really trippy because I've seen a lot of motherboards, and this one I guess it's because I don't buy motherboards from Gigabyte. But
yeah,
I understand that for the most part stuff is in the same place usually. But I could have swore that personally my fan connectors for my CPU are right there.
Yeah.
And
but that's
then
got
next
that
to
big
it is
fat
this. Yeah, next to it is the C.
And you are correct. So geographically speaking, they will be in different locations. But for the CPU connector, you see you have those big posts for the heavier duty wattage that's going to come through it. So it's a much bigger post versus the tiny little posts you have for the fans. So the post size on the CPU fan are going to be similar to the post size of these pinholes for your P1.
Problem.
Did you have another question, Nassim, or are you good? All right. So I know you're all excited and eager to give it a shot on your own. So
no.
Here we
No, I'm
go.
not.
Kelly.
Not at all.
Yes, Chris. Let's do it. Yes, Chris. Let's do it.
Come on, Crystal, be a creative mindset. Come on.
There you go. Growth mindset. Growth mindset. You can do this.
I just gave them the answers. You should have told me you had this. I forgot. Please don't use the answer sheet. Do it off the top of your head, guys.
Now you just told them where to go look for it. Terrible DW, I swear.
Where is it? Where is it? Where is it? Where is it?
Let's not use it. Let's not use it. Let's just go ahead.
Give it
and
a
try
shot
our best.
without it. Give it a shot without it. Honest attempts, remember? I'm going to give it at least an honest attempt.
Let me turn this off before I start cursing.
Like when my wife asks me to clean the bathroom, and I just spray and then wipe. Don't really brush. No.
That's terrible.
Those things don't work, right? They say, yo, just spray it, leave it on for 10 minutes, and then just.
Yeah, it's a lie.
Yeah, you still gotta scrub the crap
It's a
out of
lie.
it. Yes, I was fired from bathroom duty. It was the plan.
Yeah, it's intentional. If you do a really bad job, they never ask you to do it again.
Unfortunately, I get kitchen duty every day.
Guys, I got kicked out of here earlier, and I was in oh man, I forgot the name of the post, the link that you post. I forgot what you call it. I got a brain fart right now, but I got kicked out earlier and I came back in. Yeah.
I didn't even join. I completely forgot about that.
Oh, they need the new file link. Hold on.
Yeah, I just need the link again. I was
Yeah.
in there earlier. I just got kicked out somehow.
Hold on.
And then
No,
rejoined.
There's no excuses for me. I was paying attention and I still was, I don't know where my mind was.
But you waited for him to
I
say
don't know
something
why.
before admitting that you two weren't able to do it. You just outed yourself.
Yeah, I warned you guys. I was like, yeah, I did not sleep well last night.
So what we're being told, DW, is we need to keep everybody's names up there and up front so we can call people out.
Oh my God.
We allowed for anonymity right now, but we're gonna have to change that. We're gonna have to just open it up and be like. What's the trinity of learning? See, do, teach. Pause. All right, so here we go. Motherboard maintenance. Some things we got to keep in mind with our motherboards. You don't go in there with a regular spray cleaner and a cloth. That is not how you clean out a motherboard. That is a really, really good way to damage your motherboard. So you typically want to clean this stuff out if it's not regular maintenance being done, at the very minimum, biannually or every other year. You want to go in there and clean out the dust. And in order to do that, you want to open it up and you want to use either compressed air or a mini PC vacuum, not a standard vacuum. There are specific types of vacuums that you can use for this that do not allow for electrostatic discharge. Vacuum cleaners are notorious for electrostatic discharge. So do not use a standard vacuum or a shop vac or anything like that. They have PC vacuums if you can use that. Otherwise, compressed air to blow the dust out of the computer. If the computer is in an area where you're going to have higher debris and dust rates, like if it's in a warehouse, a machine shop, if the person has pets, most notably cats are notorious for this because they crawl behind computers because they're warm and it sucks in all that hair. You may have to clean it out more frequently. When you do open up your system to do maintenance checks on it, you want to check and make sure everything is still securely seated. You want to push your expansion slots down, make sure they're still securely in there, your RAM modules, all that stuff, because over time, you have what's called chip creep. As things heat up, they expand. As they cool down, they contract. You do this repeatedly over time, things can move. And they move just enough to where you don't have a solid connection. You can have shorts, you can have intermittent connectivity issues or processing issues. So when you open it up, after you blow the dust out, make sure everything's seated properly. Cables as well. Just touch each cable, just make sure it's still sitting, clipped in where it's supposed to be. Basic maintenance. Also, one thing you can do, back up your BIOS, especially if you change a lot of settings in a corporate environment or enterprise environment. Make sure all your settings are backed up and perform this periodically. For security reasons, on a relatively regular basis, they're usually not very frequent. You want to check if there are firmware upgrades for your BIOS to make sure your BIOS is fully up to date, has its full capabilities, and full security updates. Now, as we talked about with Adrielle earlier, this is called flashing the BIOS when you update the BIOS on your motherboard. Historically speaking, this is probably one of the most dangerous times for your computer. Because if anything goes wrong when you're flashing the BIOS, your computer becomes a very expensive paperweight. On older computers, newer computers, they're actually building in a failsafe to where you have a backup for the BIOS built into the motherboard. So if one doesn't work, it falls back to the other. But that is a very recent thing. Historically speaking, if you're flashing that BIOS, something goes wrong, it's a brick, it's done. And you'll see techs go through some extraordinary efforts to prevent that. Like they'll hook up 2 power supplies and make sure each power supply is hooked up to a different breaker. They'll have them hooked up to uninterruptible power sources. So battery backups, just in case there's a twitch in the power, they don't want it to go wrong. If you're dealing with $10,000 plus equipment, you do not want to have a hiccup like that happen while you're just running an update. So flashing the BIOS, probably one of the more stressful aspects of an updating or maintenance process that you may come across in general. Question to Sim.
Yes, I'd like to ask, first of all, how you back up the BIOS? And second of all, if you have a backup for the BIOS, what is the problem then if something like you just mentioned now happens?
Well, what you would do is you would back up, you're backing up your settings for your BIOS. So you could back that up to a drive, like an external drive or a thumb drive or a flash drive or something like that. And what I'm talking about, the backup they have is another firmware chip on the motherboard. So there's a secondary chip on the motherboard that has a backup of the BIOS on it in more modern motherboards.
Okay. And what happens when you said that there's something goes wrong with the power supply and in the middle of flashing, you lose everything? If you have a backup, can't you replace the backup back into the?
Well, not if it can't do the initial conversation with the motherboard. So remember, the BIOS is that initial conversation with the motherboard.
So
and what you're doing is you're backing up the settings, not the whole thing. So you're backing up the version in the settings. You can do that on a thumb drive. But if the BIOS that's on there, if it doesn't have a backup already on the motherboard, if the BIOS is on there and that goes bad, it doesn't have the capability to do any initial instructions.
Okay, I understand this. But what about if you take out this chip and you place it as a serviceman? Don't you have some kind of device that you can put this chip and reset the BIOS on the chip and replace it back in place?
You're talking about taking the chip off and then putting it back on?
Yes.
You're talking about unsoldering and then resoldering a chipset on the board. That is extremely difficult.
Well, if it's soldered, it's a different story. But I'm saying the manufacturer, why don't they make in a way that if such a thing happens, that a serviceman could take it out, place it in a device, reset the chip, and replace it back on the motherboard?
Why don't we make light bulbs?
Because the way you see, because the way you're saying, you lose the whole motherboard, the whole computer goes away.
No,
besides the parts,
that's the thing.
besides the hard disk and other parts that you can take out.
That's what they've corrected for now, Nassim. But in the past, it was a vulnerability.
Yeah, that's the thing. It's only something that's really really a problem on older systems. And for the most part, when you flash the BIOS and something goes wrong, say you lose power or something like that, it's just the motherboard. Your CPU, your RAM, your hard drives, everything on there is fine.
Yeah, everything else.
It's kind of like having it's like having like your motherboard lost its memory. Essentially, it doesn't have any memories anymore. It has amnesia. It needs to get a new brain, essentially. Yeah. So everything else is there, but
I understand that part, Adriel.
Yeah, it's not something that is like, oh my god, it's terrible. It's more like, damn.
Yeah,
I gotta buy a new motherboard.
It doesn't nuke the entire computer, but yeah, the motherboard itself doesn't work. You would have to basically swap out the motherboard on the older ones. But yeah, but kind of going on, why don't they make it so you can take it and hook it up? Again, why don't they make light bulbs that last forever? Because it's not a good business model to have something that lasts forever. So
the hippie in
but
me
you get lifelong
cringy.
Customers.
Yes. All right. So real quick, I'm going to try to move through this quickly. We got to go through taking a motherboard out, putting it in. Steps are going to be kind of similar to what we talked about yesterday. So if you're going to need to do a replacement on your motherboard, first, you're going to have to do the research, make sure it matches up with the equipment you currently have. So say you have a situation where you flashed the BIOS, fried your motherboard. Everything else is good. I just need a new motherboard. Do the research, make sure the components you have, the chassis, the chipset, or the CPU, all that other stuff, the form factor, all fits. Check the documentation. If it works, fits, everything else can work, you then proceed. From here, unfortunately, with the motherboard, everything has got to come out. You're going down to a bare chassis. So you want to confirm you have the right board selected. You're going to remove the components and then take out the old board. So you're going to take all those steps we did yesterday, where you make sure you unplug everything, press the power button, wait 5 seconds, take the side of the panel off, put on your whatever ESD protection you're using, being gloves or the wrist strap or the mat or whatever, ground yourself to the computer. Go in, start removing slot components, pull those out. Then you pull out your RAM. Then you start pulling out everything else. Yes,
Kelly,
Cynthia.
I'm so sorry. Can you just quickly go to slide 28 and 29? I'm trying to match my handwritten notes. I just want to get 28 and then 29.
28 is this one.
No, there are several motherboard maintenance checks. That one that says there are several
the maintenance
motherboard
checks. That's this one.
Okay, I get that. Okay, and then the next one, please. Okay, yes, I'm on. Yes, thank you.
No problem. So you're going to go through all those. You're going to get your CPU removed, your power supply, your drives, all that fun stuff, take it out. And then you unscrew using that X pattern, pull your old board out. Then you're going to need to upgrade. If you're using a totally different motherboard, you're going to upgrade the I/O or input output metal plate that'll have that cut out for all the external ports you have for your motherboard. Reinstall that. Then you're going to mount the board back into the tower, being careful to only hold the stuff by the edges. Screw it back down in the X pattern that we talked about earlier. Then you're going to install your CPU, reinstall the fan, the RAM, components, cables, PCI cards, and then close her up, attach your monitors, keyboards, all that fun stuff. It's very similar to the steps we talked about yesterday, just in a little bit of an abbreviated fashion. After that, we're going to go in, and when you first turn it on, you're going to have to configure the BIOS because it's new to the party. It has to know how to be able to talk to everything. So you got to set your date and time, disable abbreviated post, set your boot order. Where does it go to look for your operating system? Does it go to the USB first? Does it go to optical drive? Does it go to your hard drive? Does it go to the internet? Where does it look for the operating system? That's your boot order. Next, ensure your SATA is enabled so that it can communicate with hard drives, if HDD or SSD. Make sure your hard drives are compatible and visible. Save your configuration and exit. Make sure it's seeing the RAM. Like if you have 4 RAM modules in there, make sure it's seeing all 4. And then you can set it up whether it's going to be single, dual channel, triple channel, or quad channel, depending on the motherboard that you have. After that, runs through, it's going to observe the post. Hopefully, if everything is done correctly, you have no beeps, no errors present. Then you can install expansion cards, other drivers as needed. It may have basic ones in there so it can do bare level communication. If not, then you need the drivers to install for it to be able to communicate. After that's done, reboot the system as needed, and you can make minor adjustments to your operating system or BIOS. Don't worry. Lots of fun practice with this in the labs. You have a few labs at the end of your modules today, due for Sunday. That goes into your BIOS and all that fun stuff, so you will get practice. All right, BIOS settings and utilities that you'll come across, firmware upgrades. We talked about that earlier. That is called flashing the BIOS. That's upgrading your BIOS. You look for your component information in there, just make sure it can see everything and it's compatible, RAM, drive, CPU, all that fun stuff. Many of them have built-in diagnostics where it can kind of tell you where everything, how everything's doing. It can monitor what's going on in your system, temperature, fan speeds, voltages being used, clock speeds on the system, even intrusion detection and bus speed. There are security things you can put in place. We talked about passwords, enabling devices. You can also set up date and time, which is not a security issue. Tells you clock speed, BIOS security, where you can set up passwords, encryption, things like secure boot, and LoJack. For those of us who were alive during the 80s, LoJack used to be a security system for cars to help you locate it. Same thing on a computer. They have a version of LoJack, so you can kind of, if somebody steals your computer and turns it on, it helps you locate it. It calls home. It lets you know where it is. So they do have a version of LoJack in the BIOS. All right, questions so far? Again, you will have time to play around with this. Also, if you're going to do something that's called overclocking your CPU, which is, kind of revving up the engine on your CPU a little bit, you would do that also in the BIOS.
Yeah, so about that, everyone, and I mean like everyone I ever talked to, have always recommended overclocking your PC.
Yes.
But I mean, unless you have like a really good cooling system, like, I don't know, the liquid, I feel like you run the risk. And what
even
is the risk,
even with liquid cooling, you still run risks. So say your car, you saved up a long time, you bought this brand new wonderful car. What if every time the light turned green, you just stomped on the gas every single time? What's that going to do over time?
You flood the gas, right? Like
you're flooding the gas. You're gonna it eventually it damages your engine over time. Yeah. If you're running it flat out all the time, over time it can cause damage or shorten the lifespan of that chip.
Yes.
So liquid cooling, yes. Now, wonderfully, many UEFI systems have a gaming mode that you can turn on and overclock it for short periods of time. So it's not running in an overclocked state all the time.
And I don't even think they're overclocking it, Kelly, because I think they're cheaping us out essentially, because I'm sure that it can run under load at that speed for a long time. They just want to turn it, they want to say it's turbo and sell it to you at a lower
Well, no, what I'm saying is like in UEFIs that you can make those settings yourself. I know what you're talking about, like Alienware has like gaming mode.
No, my CPU itself, or the motherboard, it has that too, and it says it's just like turning turbo on for the AMD thing. I think that the CPU is like that anyway.
I got a pretty entertaining story about that. I'll talk about when we get to CPUs. So we'll put a pin in that for now, but I will get into that with CPUs. All right. So here we go. Here is a look at the old school BIOS. It'll be that gray and blue color. UEFI can look like this as well, but typically in BIOS, you're going to be using, again, the arrow keys to move between menus and select things. UEFI allows you to at least click with the mouse. Sometimes it can look like this, but more modern UEFIs look much like the earlier picture we were looking at. All right. So real quick, common pitfalls. A lot of people are like, it's real quick, I've never had an issue. So they'll go ahead and they'll try to run in and just open it up real fast, get what they need to done and close it up and forget about their ESD safety. And all it takes is that tiny little spark. Remember, to damage a electronic component only takes about 100 volts. And I believe humans can't feel anything less than 3,000. And we don't see anything less than 10,000. So when you reach for a doorknob in winter and you get that little fun little spark that you see, that's 10,000 volts. And it only takes 100, so you wouldn't even feel it to damage a computer component inside your system. So not worth the risk. Don't want to buy new stuff if you don't have to. Make sure you take your proper safety precautions. Use your ESD bracelets or gloves. Don't wear jewelry, tie back long hair, all that kind of fun stuff. Yes, Ramon.
Okay, it says never use magnetized tools, but I was going through the lab and it said use a magnet rod to collect screws.
No. Do not use a magnet rod to collect screws.
But that's in the lab, that was the correct
in what lab?
answer. Like going through the 2.0 It's one of the twos.
Okay,
Thought
I
it
will
was
look into that. I will look at that, but yeah, no, that is typically no. It may be, I'll have to look at that question because it may say what is not the correct thing to use, because they have 3-pronged things that you use to pick them up, because you don't want to use magnets inside your chipsets. So I'll have to take a look at that specific one you're talking about, Ramon. So yeah, no magnetized tools. Don't put magnets inside of a computer. That has generally been the rule as long as I can remember. When you're tightening screws, putting your motherboards and stuff in, this is not a tire on a car. You don't need to bear down on it. You know, you're not going to be taking this thing off-roading. It's like finger tight and 1/4 to 1/2 turn is usually what you're doing. So don't over tighten them because you can damage or crack the boards.
Or strip them.
Or strip them. That is a good point as well. Try not to cross thread. If it's not going in easy, something is wrong. All right. Some common issues you may come across with a motherboard: burning smell. That's never good with an electronic. Typically, if you smell that or see smoke coming out of an electronic item, shut it down immediately, typically with the effect of ripping the plug out of the wall. Computer doesn't boot and gets the beeps. If we get the beeps, what is that? If I'm booting up my computer and I get
Something's
beeps.
wrong.
Well, what's wrong? What does that represent?
Power on self-test.
Power on self-test, post error. You get the beep, beep, beep. Power on self-test, post error. Excellent. Then we either go to the documentation of the motherboard, figure out what that post error means. Some motherboards they have the error code on the motherboard itself, or you can go online and say, figure out what the beeps mean as well. Typically, if you get a post error, it's whatever you were messing with last. Cannot log in using your BIOS password. Who wants to tell me how do we get past this? There's a BIOS password. How do I get past that? I forgot it. I haven't put it in like a year. What do I do?
Take the battery
Unplug
out.
it.
Pull out the battery.
Pull out the battery, or
Jumper.
Press that button.
jumper pin.
Yeah.
There you go. Pull out the CMOS battery or the jumper pin if I can't get past the BIOS password. There are cases that have come up where IT departments didn't lock the cases, didn't really do anything with the BIOS, and then an employee will go in and set a BIOS password, and if they're disgruntled and they leave, they'll kind of do that just to cause problems. How do we get around it? Remove the battery or hit the jumper pin. Buttons on the front panel are not working. Where might we look for that? I just built my fun new computer. Everything seems to be working right, but the buttons on the front aren't working. Where do I need to go?
The connector for the front.
Front panel connectors. They might have been lined up incorrectly. So
Manual.
Yep, I would check the manual as well. Yes, always go to the documentation. All right. Motherboard lights up but will not power on. May not be getting enough power. So you're starting to get a little bit of juice, but it won't fully power on. The other one, hardware not recognized by the BIOS. You likely need to do an upgrade to you need to flash the BIOS to get the upgrade or download additional drivers. We talked about that with the CPU. Make sure it's compatible because sometimes you need an older CPU to upgrade the motherboard so that it will accept a higher end CPU. But you will get practice flashing the BIOS. I believe there is a lab for that. And if you are not comfortable with it, I do encourage you, even if you get it right, don't just move on with your life. Come back to the ones that you struggle with and practice. Build that muscle memory. Yes, Kayla.
That last sentence, no matter how many times I repeat it in my head, does not make sense to me. It needs an
Which one?
older version PC to read.
No, older
it.
version CPU. So say when the motherboard came out, it needed a version 8 CPU, just to be generic. Well, after the motherboard was originally created and put on the market, a version 9 comes out. Same socket size and it's compatible technically, but the motherboard needs to be updated to be able to accept the new version that was made after it was.
Okay, yeah, okay, that makes sense. Thank you.
No problem. All right, just trying to. So, motherboard is overheating. Check your fans, check your inputs, especially if you have pets or if you're in a high dust or debris environment. Please try not to put computers directly on the floor. At least have them raised up a little bit or on top of your desk. That way they're not on the floor sucking in, the majority of the dust gets kicked up. Not enough power. This is where the documentation comes in. Make sure your power supply is up to the task. If it's still having issues, you may have a bad power supply. Does happen. And a power supply that is failing is probably one of the more annoying and difficult things to troubleshoot, because all symptoms are intermittent. It may not, and it seems to be kind of all over the place. Incorrect components installed, refer to your documentation. If you're starting to get post errors right after you put it in, one of the first things I recommend checking is usually your RAM, because that is usually the one thing that is improperly seated when people put the computer together. That tends to be the most common issue. And then we talked about the case buttons being corrected, hardware compatibility, and shorting the board. Oh, I'm sorry. We'll do a quick time decline. Y'all haven't done these yet. And then be pretty good to go to lunch after that. Devin's playing alone. There we go. So wrapping it up real quick. Objectives, we should now be able to explain the key role of a motherboard.
You're not sharing, Kelly?
Of course I'm not. We should be able to describe and identify the components and typical interfaces found on a motherboard. Identify required maintenance checks, steps for removing and replacing a motherboard, common problems, and how we would address those. Questions, comments, concerns, complaints, revelations.
I did pretty well in the last test, but this whole session has kicked my ass, man. Like it's been, yeah, I'm not a hardware guy, so I have to sit down and study.
I get you. We're going to start, now we're starting to do deep dives on each of these components so we better understand them. So we're going to start looking at them in a little more detail.
I think Eric is another guy that built a computer here.
I was saying, sorry.
No, it's okay. No, it's okay.